So in this lesson, we're really focusing around interpreting graphs and figuring out kind of like what's the story behind a graph. These graphs are mainly going to be functions. We're going to be taking a look at different things like independent variables, dependent variables, how do we read the scale, all that kind of stuff. First off, let's kind of just take a look at the scale. Let's take a look at the graph and let's see if we can figure out what's going on both the axes. So I like to call this horizontal axis, this is really like the independent variable axis. And we can see that this is time. So this is measuring time. And it's denoting that the units are in hours. And you can see that they're setting their scale as every tick mark or every one box is every half an hour. So I don't want to say 30 minutes because then we're mixing units up, but we could say that this is 0.5, 1, 1.52, and kind of keep on going up like that. Let's take a look at our vertical axis or our vertical values over here. This is going to be our dependent variable, and this is distance, or it's measuring distance of the car ride, and this is measured in kilometers. And as we can see that every box going up is going to be 20 kilometers each. This is called our origin. So just like really briefly, just talking about a couple things. This is our origin. This would be the coordinate of 0, 0. So t is equal to 0, our time is equal to 0, and our kilometers are equal to 0 as well when we start our trip. And then we kind of have each section over here. So let's take a look at section 0, or O to A. So O to A, you can put an arrow in between these, you can put a little line above it, doesn't really matter, but we're just going to be linking O and A together. And let's kind of maybe just describe this. So of course time is going on, right? We would never work backwards through time. So as time goes on, it looks like we are increasing our distance away from Winnipeg. If Winnipeg was at the origin, since this is a day trip from Winnipeg to Winkler, so Winnipeg's at the origin, and we're going up to A. So traveling for 1 hour, it looks like. Looks like it has 1 hour time traveling. 1 hour. Let's spell hour properly. 1 hour. It's away from Winnipeg. I'll just denote it as WPG. I think everybody kind of knows that abbreviation for Winnipeg. Traveling 1 hour away from Winnipeg covers 60. You know what? No, it's kind of right in the middle of 60 and 80. So I'm actually going to back that up a little bit. And I'm going to put that covers 70 kilometers. And that's kind of our distance from 0 to A looks like it's right in between this. Hey, if you want to put it's like 62 or 65, that's fine with me, but I just kind of read this as 70. Make sure it's not 60, make sure it's not 80, let's put it that way. And it took them about half an hour, or it took them an hour to do. Let's go to our next section, A to B. A to B, there's absolutely no change in distance, so they're stopped. Don't know where, but they're stopped for sure. And it looks like they're going for about half a block's worth or half a square worth. So if 1 square is worth 30 minutes, is worth half an hour, then this is a half of an hour, if you can follow that. So this is a quarter of an hour. Quarter of an hour. If you really wanted to, you could put 15 minutes. That's cool with me. So stopped, quarter of an hour. They're not traveling any distance whatsoever. They're stopped. B to C now. They're back traveling. If B started right about 1.25 and we went to 2, then it looks like they're traveling about 1.75 hours. 1.75 hours. This would be equivalent to 1 hour and 45 minutes, by the way. 1 hour, 45 minutes. If you wanted to, go ahead. 1 hour, 45 minutes. Again, it's going to be away from Winnipeg. And it looks like we're covering, if we said this was 70 and that was 130, if that was 70 and that was 130, well, it means that we've covered 60 kilometers. 60 kilometer covered. I believe at this point at C, we should be at Winkler, since the distance between Winnipeg and Winkler is 130 kilometers, and that's where we're at right now. We are at Winkler. So that's kind of where B to C is. We drove getting away from Winnipeg, but now we've kind of like reached our destination. So C over here, we are actually at Winkler. And it looks like we're actually going to be in Winkler for the foreseeable future. For these 2 hours, we're actually going to be in Winkler for it. So kind of CD, again, we're stopped, but we're in Winkler. We're in Winkler for this day trip or whatever it is for 2 hours. And that's, now we're at D. And as we can see from DE, that's kind of like the last leg of the trip. DE. We're now moving back towards Winnipeg, right? Because our distance from Winnipeg is now going down. So traveling. And it looks like we're traveling for another 2 hours, 4 to 6, traveling 2 hours to Winnipeg. And we're going to cover 130 kilometers. And I just want to kind of point out a couple things about this. First off, in every single one of my descriptions, I have been talking about my independent variable or my independent values of time. I've been talking about time, and I've talking about distance. I've talked about both of these things in relation to how much time it's taken on each portion of the trip and what's the distance covered in it. So I'm talking about both of my variables I'm talking about both my values and my axes in each one of these descriptions. I'm also indicating the direction from Winnipeg as well. While we see that in our 2 trip, we see that we're going away from Winnipeg, so we're traveling up and up away from the origin, we can see that on our trip back down, we're traveling towards Winnipeg since our distance is coming back down. So I'm linking my horizontal axis values or my independent values with my dependent values in my description, and I've also indicated the direction of how we're traveling as well. And that should be a really good description and tells everybody what's going on in that graph.